Let T of T denote the temperature capital T in New York City measured in Celsius degrees or degrees Celsius when it's T lowercase t hours after midnight on a given day. The function is graphed below. The following table contains true statements. Match each statement with the feature on the graph that most closely corresponds to it. So once again, this is capital T as a function of lowercase t. Temperature is a function of time. So we see at time equals 0, the temperature is -3 degrees Celsius. And then as we go to 8 hours later, the temperature is at 0 degrees Celsius. And then it hits at least a relative maximum point, or at least from what we see, it could even be a global maximum point, but based on what we see, it's definitely a relative maximum point, 14 hours into this measurement at time equals 14, and then the temperature starts to go down again. So let's see. So and this is T hours after midnight. So this is at midnight. This is going to be at 8 a.m. This is going to be at noon. And this is going to be at 2 p.m. and so on and so forth. But anyway, the feature, y-intercept. So the y-intercept is right over here. And we see when lowercase t, when time is 0 hours after midnight, the temperature in New York City is -3 degrees Celsius. So it was -3 degrees Celsius at the beginning of the day. Yeah, that's a true statement. And especially if you consider the beginning of the day, the true beginning of the day is right at midnight. So that's that one. The y-intercept tells us this true statement. So positive or negative interval. And these questions are a little bit tricky because you don't have to use it's the positive or the negative interval. It doesn't have to be both. So if either the positive or negative interval helps you with one of these other two statements. So let's see. It was getting warmer between 2 a.m. and 2 p.m. The temperature was above 0 between 8 a.m. and 8 p.m. So let's see. If we're talking about positive or negative intervals, so we're not talking about increasing or decreasing. We're talking about positive or negative intervals. So we have a negative interval. We have a negative interval from time equals 0 to time equals 8. And what do I mean by negative interval is the temperature is negative. It's below 0, and then from 8 hours, from 8 a.m. to what is this? This would be noon. This would be 8 p.m. From 8 a.m. to 8 p.m., or the 20th hour, if you're thinking in military time, so to speak, we see that our temperature is positive, and then it dips down to negative again. So a positive or negative interval tells us when our temperature was above or below 0. And we can see we have this positive interval where the temperature was above 0 between 8 a.m. and 8 p.m. So we're only using the positive interval. This interval right over here where the function is positive, that means that the temperature was above 0 degrees Celsius between 8 a.m. and 8 p.m. So once again, it's saying either the positive or the negative interval helped us make this statement. In this case, it was only the positive interval helped us make this statement. And then finally, we have increasing or decreasing interval, and it was getting warmer between 2 a.m. and 2 p.m. It was getting warmer between 2 a.m., which is right over here. So we see that the function is increasing. As t increases, so does the temperature, all the way to 2 p.m. And that right over there is an increasing interval. So once again, we're not using an increasing and a decreasing interval. We're just using the increasing interval. The decreasing interval isn't helping us to make the statement, but the increasing interval is letting us make the statement. It was getting warmer between 2 a.m. and 2 p.m. From here to here, or between 2 a.m. and 2 p.m., we see that the function itself is increasing. That is an increasing interval. And we got it right.